and, oh, I just lost it. Okay, 3 and 4. So in 3, 26.3, or 23.6 feet squared. We have to eventually get to centimeters squared. So I wrote those couple of like random conversion factors you might have needed on the board yesterday. So the foot and centimeters squared have no relationship really. So instead of going from feet to centimeters squared, what would be a logical step? Feet to inches likely. So if we know that feet and inches have a relationship, we know we have to write the stacked units this way because feet have to cancel with feet. What's this relationship? 1 foot is 12 inches, right? But here's the weird part. When you have a squared unit, you are going to square all the units here in the conversion factor and the numbers in the conversion factor. So that's feet, or 12 squared, inches squared, feet squared, 1 squared. So the feet squared cancels, but we're going to keep the rest of this for a moment. And then lastly, we're going to centimeters squared. And I spoke yesterday of one conversion between centimeters squared, centimeters and inches. So I know I want inch on the bottom because I need to cancel inch, and I want centimeters on top because I need to go to centimeters. What was this relationship I spoke of? 2.45 or 2.54, right? Yeah. 54. Okay, so 1 inch is equal to 2.54 centimeters. But since this is a squared unit, what am I doing to all this? Squaring the whole shebang, right? So inches squared, centimeters squared, 2.54 squared, and 1 is squared. And so therefore, inch squared can cancel. So in your calculator, you're just going to put in 23.6 times 12 squared times 2.54 squared. And what do we get? If you need a calculator, grab one. Or Malcolm will walk around with a calculator box. Yeah, thank you. Okay. Raise your hand if you need a calculator. It'll become habit. You'll grab one on the way in. I know, it's like first week still. So we should have gotten kind of a big number. 2.91 or 1925 times 10 to the 4th. And then how many sig figs should this contain? 3. So this will be 2.19 times 10 to the 4th centimeters squared. So that's 3. Thank you. And then 4th. Yes, you guys are right. Those are probably one of the more challenging ones because this bottom one's going to use a relationship between milliliters and centimeters cubed. So grab that. Can't grab that. Okay, so 952 grams per liter. 952 grams per liter. All right, and we want to go from grams per liter to, what was it? Millimeter cubed. Okay. So the relationship I spoke of yesterday was that 1 milliliter is equal to 1 centimeter cubed. It's a unit of volume that we often kind of just use interchangeably. So if we're starting off with 952 grams per liter, and I see this relationship start to form, I know I can't go directly from liter to millimeter cubed for sure, but I can go from liter to what that looks familiar over here. Well, I can't really go directly from liter to centimeter cubed because that's volume and then volume in another form. So I'm going to go from liter to milliliter because liter and milliliter have a relationship. So if I put liter up top, it's going to cancel liter. If I put milliliter on bottom, I'm going to get to eventually to this looking weird volume. And what's this relationship? Oh, so King Henry died by drinking chocolate milk. Where's liter out here? Base. So if I put a 1 on liter, the 1 always goes in the bigger unit. There's 1,000 milliliters in a liter. So I heard both, so just make sure we're on the same page. Okay, and then liters cancel out. And now I can proceed taking milliliters to a form of volume that's like a length times width times height kind of unit. So what is this going to have to be converted to? Potentially what? Centimeters cubed. So it's just a 1-to-1. It's not going to change our numbers, but now we're getting to the type of unit that we're looking at here in the end. So 1 milliliter is equal to 1 centimeter cubed. And that's just because I now know this, and if you don't know it, write it down so you can put a star by it. We'll use it somewhat frequently. So milliliters cancel. Centimeter cubed is still there. It's centimeters cubed. Okay, it's there. All right, so then finally, I can see this centimeter cubed looks kind of similar to millimeter cubed, so we can get to that final relationship. What goes on top? Centimeter, and goes on bottom? Millimeter. What's this relationship between centi and milli? So 1 and 10, right? So who gets the 1? Centi, and who gets the 10? Milli. So there's 10 millimeters in a centimeter, and since this is centimeter cubed, we're cubing all of this as well. So only, weird one with the cube. And then we'll notice now centimeter cube cancels, and now we have the units of grams per millimeter cubed, which is what was asked for, and we can calculate. So 9.52 times 10 to the negative 5. Open. So negative. Any takers? Oh yeah, sorry, negative 4. And grams per millimeter cubed. All right. So this was really the only tricky section here and then here on that one. So hopefully that answers those questions. All right. Can I proceed past the 2 types of problems we did first yesterday? Can I go to word problems? Shake your heads, okay? Because I do want to see, look at your lecture notes, because we have like maybe 4 that we're going to do on there. And that's what was on the board for warm-up. And then we'll go from here. So these look pretty different than what we were doing just now, right? Like in the story, it's like, look, I have a piece of lead, or look, I've got some particles moving in gas, or I've got some seawater. So don't get lost in the story. It's super interesting, I know, but don't get lost in the story. The reason I'm giving you word problems is because you'll be expected to pull information out of the word problem. The 3 pieces of information you're always looking for are 1, the starting point, which is the given, 2, a conversion factor, which has like a fraction, or the word per, something like that in it, and then like the legit question, like what am I solving for? So, will you halfway close your computer so I know that I got your full attention? I can't compete with the internet, it's way cooler than me. Okay. Alright, so the density of lead is blank. This piece of information is important, right? Is that the given, like a starting point, like a fact, or is that the conversion factor, or is that the question? That is the conversion factor, right? It looks like a fraction, right? It is the conversion factor. So just on your paper, write down CF, conversion factor, 11.3 grams per milliliter. Now, I'm just starting you off like to set you up for success. I'm writing it out very clearly what each of these things are, but after that, we'll kind of do it on our own, how we wish to do it. Okay, so what's the question, guys? What's it looking for? Mass. Okay, so what unit is mass? It is going to be in grams, so the question is grams. Okay, so we're interpreting so far. And then what's the given? 45. So 45 milliliters is our given. Okay, so this was kind of at the beginning of notes yesterday where we talked about like one piece of information was our given, and that's always our starting point. Then we use conversions to convert. So what's my starting point? 45 milliliters. Do your little fraction bar thing. Okay, check, I've used this. Now I have to use a conversion factor because I have to cancel out milliliters. That's the only unit I have to cancel. Do I want to use this conversion factor as is or flip? As is, because what's already in the denominator? Milliliters. So if I put it there as is, 11.3 grams and 1 milliliter on the bottom, what cancels? Milliliters, so let's check. We know it has to cancel. And then what unit have we achieved? Grams. Yay! That's what we wanted, right? We wanted grams. So we have grams, so now we can calculate. So literally 45 times 11.3. 508 what? 0.5 grams. Okay. So how many stick figures should I have, Garrett?
You should have
So where are you seeing 3 on my givens?
Givens. You're going to need 2.
2. So the 2 sig figs is the initial measurement that we have here. So can you round that to 2 sig figs for me? Just 508.5. I want you to round it to 2 sig figs.
510.
510, right? So we want the 5 to be O, but the 8 is going to influence the O or the 0 to round up. So that would be 510 grams. Beautiful. Okay. So I just talked through finding the 3 most important pieces of information. Go ahead and do that for 11. Talk to your partner about that. If you can identify all the pieces, go ahead and put the puzzle together. So get the mental analysis started. I saw a lot of you guys setting this up correctly, so that's why I'm solving it right now. So as you were reading, the question came to you as far. That doesn't necessarily tell you the unit it's looking for. So I'm sure many of you guys stopped at a length, and we were told this conversion factor of 15 kilometers per second. So who stopped at kilometers in calculations? Okay, raise your hand if you stopped and you have kilometers on top. Okay, that's great. It doesn't specify it has to be a certain unit. So if you want to stop at kilometers, that's fine. But I want to make sure we can convert further. So I'm going to specify this far to be in meters. So now take your process of your given of 5.5 seconds, 15 kilometers per second. That's a conversion factor. We cancel seconds out. What am I going to write next, Charles? For my next conversion if I'm going to meters. Think about those numbers. Good. So 1 kilometer is big, right? So it's the larger unit. So we put a kilometer on the bottom. There's only one of those. That's going to cancel this kilometer out. And then in 1 kilometer, there's 1,000 meters. So the kilometers cancel. And how many meters is that, Charles? 82,000. And that's after rounding. So it was 82, 500-ish, right? Meters first. And so why'd you round to 83,000? So we only have 2 sig figs, right? So this little particle of gas, which is flying around your head right now, in 5.5 seconds moves 83,000 meters. Holy moly, right? Wish you were that fast. But gas particles are high in kinetic energy, so they do travel that quickly. Okay, now, the next one has a lot of words. Pick out the things you need, okay? And then we'll talk. These are on your left hand, so you don't want to leave with it on the board. So I see you for processing. Can you just shout out the get for me? 15 milliliters, right? So that's the only factoid that's given that's like singular. It's not a unit over a unit. It's not a conversion factor. Okay, so we all should be at this point. And as you look farther, you start to see the conversion factor. It has liters in it. Think about how you're going to address the milliliters so that you can actually use this. Okay, so that's your next step. Thanks. You're already ahead. All right, come back to me at this point. 3, 2, 1. If you're in the middle of a conversation, just hold off for a moment. So for those of you who are on the struggle bus, this bus is about to crash. We got to get off, okay? So we see milliliters. We know that we can't use milliliters immediately because in our reading we saw 6.227 grams, blah, 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 per liter. Per means slash. So that's telling you a conversion factor of 2.77 grams per 1 liter. So this conversion factor is the only thing you can use to get from liters to grams, or grams to liters if you want to. So since we have milliliters to start with, I can't use this yet. So I have to get milliliters to what first? Liters. So I know that liter has on top, milliliters goes on bottom because milliliters are can cancel. This relationship using King Henry died by during chocolate milk is, which is the bigger unit? Liter, so it's a 1. And then how many, from the base, how many zeros away is meter, or is a milli?
1,000.
1,000. So it's a 3-0 system, so that's 1,000 milliliters. So this is going to cancel. Score. Okay. Now I've got liters. Now what can I use? The actual conversion factor now. And that's the only way I'm getting from liters to grams, is this conversion factor. Because otherwise there's no relationship for us at all. So that's 6.277 grams per 1 liter. And I had to arrange it this way because liters was the thing to be canceled, so it had to be on bottom. And liters cancels, grams is still on top. So Mason, what would be my last step?
You multiply your top together and then run right on.
I'm not done yet. Look at the question. So what's my question here? Like the unit.
We need to convert the milligrams.
Okay, so I'm in grams right now, so give me some milligrams.
You need 1,000 milligrams for 1 gram.
Okay, so grams going on bottom because it needs to cancel 1 gram. And in 1 gram there are, from base, there's 3 zeros over, so that would be 1,000 milligrams. And before I start calculating, you guys notice anything that's nice here? Cancel out those thousands, right? Because, you know, you don't need to put more in your calculator than you actually need to. So these thousands can cancel. The grams have already canceled. There we go. The only unit left is milligrams, so this answer will be in milligrams. So now when you calculate, go ahead and you guys calculate. Tell me what you got. Simon?
The calculator gave me
94.155.
94.155.
And will you round that to correct sig figs? 94.2. So where are you getting the sig figs from? Okay, so there's our 3 sig figs here, and then you said 94.2. Perfect. All right, so I know the word problems are they take a second moment or another second to kind of get your thoughts together. So who feels like they're closer to a 10 now than before we started? You know, out of 10, you're good. Okay, let me do another one, just so I want to try to get us all on board here. Let's go to 14. Okay, talk this out. Like, talk to the person next to you. How do you know all the pieces? Don't just tell them answers, talk to them.
So we can go, we already know we can start at 15 grams.
What do you guys feel comfortable with the question?
So you just do 15 like that. That's how big of a mold. So that's like, this would be how many, how big of a what mold is.
Just give me a thumbs up if you're good. Like you know what you're doing. Alright, keep working quietly. If you're not good, you just need to peek up here to see where we're going. I'm going to read this question to you like I would normally read this. Blah, 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 blah. Ooh, conversion factor. Okay. Blah, 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 blah. Ooh, another conversion factor. How much heat? Okay, that's my question. That's going to be important later. Blah, 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 blah. Ooh, a given. Blah, blah, blah. Okay, so literally that's all you have to do. You can highlight or circle the things that are actually important to you because none of the storyline matters. We're looking for conversion factors and then givens and questions. So I know these are conversion factors because what do I see in them? That's kind of a dead giveaway. The slash, the fraction. So it's fractional, it's got 2 units in it. This is the given. So I have 15 grams. I know I have to cancel grams. Which of these is my go-to? Because it's got grams in it, and that's the only way I'm going to cancel grams out. So 18.0 grams per 1 mole is my next conversion. But I flipped it because grams had to be on bottom. So grams cancels nicely. And then check. I've used both of those. Can't use those again. So then I have to resort to using this conversion factor or one I make up from the metric system. I don't need the metric system because I see mole, and then I also see kilojoule. Why is that important to see? Because that's what you're looking for, the heat. So we have to use this one. So I'm going to take it as is, 254 kilojoules per 1 mole. And now grams have canceled, moles have canceled, I'm left with kilojoules. So in calculating, I see that I met my final destination, and I know so a couple of us have already gotten there. So we're doing 15 in our calculator divided by 18.0 times 254. And what do we get? 6 repeating, and that's kilojoules, okay? So if I look back at sig figs, my measurement has 3 sig figs, and then I need to record this to be 212 kilojoules. All right. So we took the 1, we saw the 6 next door, we rounded that up. Okay. Open up problem set 3B on your computer if you print it out. Let's just get some independent practice in so that I know you're safe. You're going home, and I'm not going to get like a million text messages for homework, okay? I'm fine with like, you know, 1 from each of you, but I don't want to have like 15 from each of you. Okay, so here's my deal, because this problem set is a beast. I told you this yesterday. We've done a couple from here, check. We've done a couple from here, check. We're going to do half of 1 through 18. So how many are you doing? 9, okay? Do not just do the first 9, because it's all density stuff. Do a couple from the first half, and then down on the bottom, 16, 17, 18 have some of those like nice word problems there that we were just practicing. And you will see some of these on your test in a week, Wednesday the 7th. Thank you. So you will see those. I'd like for you to practice them so I can give you some help. So take a little bit right now. Let's say 15 minutes and see where we are, okay? So you're doing 9 from the lower half. And I'm here to support. I get paid for this, so use me, please. If you'd like to move to a lab station to work with a buddy, you can. If you find somebody that's good at explaining something for you.
Here. So it gives you the density. So let's say here. So
So you guys went through your Edpuzzle video. I can see like how long you spent. I can see every detail of your life on Edpuzzle. I can see how many times you watched the video, how far you went, what questions you got wrong, how long it took you, like the whole gamut. So if you don't watch the whole video, I mean that one wasn't that bad. You don't get your full credit, so don't jip yourself there, okay? So you guys watched, you saw the matter, this little table of pure substances versus mixtures. That big difference there will cause some differences in the way we look at things. And then you saw this very last piece, right? Okay, so the last piece was basically you saying I can decide based on an image if it's a pure substance or a mixture. And what are the 2 branches of pure substances? Compounds and elements. And then in mixtures, there's 2 varieties. Homogeneous and heterogeneous. Okay, so I'll just give you the quick of this, and then we're going to do this activity. With the connected dots, those are 2 elements connected together to make a what? Compound. That's a chemical combined or chemically combined compound. That means there's like a chemical bond there, like a covalent bond or something like that. But when you see a singular one, like down here, this is not a compound. That little black dot there is not a compound. It's a what? It's an element because it's a singular atom. Okay, but this collectively is called a mixture because it's a mix of 2 pure substances. Element black and element yellow. And then this is also a mixture, but it's a mixture of not elements, it's a mixture of compounds, compound green and compound blue. So the mixture there is still going to be, a mix of things, but they're a mix of different types of things. So instead of saying things all the time, we're going to say elements or compounds, okay? So choose a partner. So capture them with your eyes, wink at them, smile or something, okay? So you have a perfect partner, but it's beneficial to talk it out. Just turn around for me back here. You're going to pick up a yellow sheet of paper. The yellow sheet of paper has basically the instructions. It says on the paper A through infinity or A through R. The cards are numbered or lettered A through infinity. So do use all the cards in your little baggie. But notice the cards come in like sets of 3. You see this? Okay, you're signing out. Alright, okay. So I did not cut these baby small because I mean we'll lose the baby small pieces, so you want to use the big card. So consider these 3 separate cards. Okay? All the instructions are here. Grab your partner, come back up. Grab a piece of these. Yes, I'm sorry. Yes, you need a piece of paper. You can share a piece of paper if you wish. You have like 10 seconds on partner. You don't want to wait. And you guys can find a lap page and you can definitely find a seat at the desk, so it doesn't matter. Okay, someone. You do not have to get your textbook to define that. You can define it in your own terms, even in your notes. If you are sharing a paper, I still want to see you actively involved. So you got to be sorting cards and locking it out. I think we're just supposed to write it down.
No, I wouldn't have. I know.
Alright, so classification matter is in the box. The card sets are back there. You're logging into Kahoot. We're going to do this. And then we'll put laptops up. And Kahoot. Ish questions. I'll watch the time. I'll make sure we have enough time to clean up. Alright, so don't like put Beyonce because I won't know who you are, so just put like a version of your name. I'm fine with that. As long as I can figure it out. Alright, so if you're logging on still, the code is 3, 2, 4, 7, 1, 3. All right, we're rolling. I already got the code on the board for you slowpokes. All right, so this is all about matter. Some of these are 10-second questions. Here we go. Anything that has volume and mass is called? Yes, I love that sound. One more? Okay. Very good. Matter it is. So that's just the definition. Next. This example is best known as muy bien. It was a trail mix. Wow. Good. Okay. It was a mixture of things. Very good. All of these are mixtures except yeah, you have to stand up and do that. What? Okay, hold up. Pause. So when we get like a little blend of answers, I gotta make sure I explain. Lemonade is made up of water, lemons, sugar. It's a mixture. Pizza, the marshmallow, air, sugar, corn syrup, amongst other things. Keep going. This type of mixture occurs when all parts are equally mixed or the same. Alright, you got one more person? Okay. Very good. If it's uniform throughout, you can't tell the difference. You would say that is a homogeneous mixture. These types of matter are listed on the periodic table. Woo! Alright, periodic table of elements. Very good. 2 or more types of matter put together but not chemically combined. Okay, so most of us are saying not chemically combined, so physically combined is a mixture. Chemically combined should be called a compound. A type of mixture that is not all the same but is made of different pieces, so it kind of looks different throughout. Alright, you got this 29. Woo! Believe in you. Very good, guys. Keep going. All the following are compounds except, look closely. Yay! Okay, gold is the only element listed, meaning it's not a compound. Water's got 2 elements involved, salt's got 2 elements involved, and sugar's got 3 elements involved, so those are all compounds. Nice. Any or a type of matter made of identical atoms. Woo. Okay, so there's a nice split between 2 here. So if I have, does anybody have any jewelry on? Yes. Jewelry? Okay, so we got some rings let's look at here. So let's pretend your rings are made of platinum, so PT all the way. Right, so that's individual atoms, but this is a full structure made of individual atoms that are all the same atom, but they're simply just the same element across the board. The only thing I see, oh, actually no, green homogeneous, what the heck is that? You never heard that word? So there's no way you would answer that. Okay. Putting two or more different elements together and creating something brand new. So creating something like a new chemical. Sounds boring. Oh gosh. There it is. Okay. Sure that happened that way. Okay, I'm good with that. If you make something new, you are making a new compound or a new chemical. So not a heterogeneous mixture. The making something new to use should now mean making a chemical bond. All right, what's the best example of matter? So we had those like quick answers now. The final answer would be everything. Very good. All right, so log off, laptops up, okay? Or shut down if you can. Log off or shut down. We have 5 minutes left, so I'll chat with you for a minute. Plug it up in your spot, please. Don't be lazy. This is lagging. So pack up so I can talk to you for a minute about stuff on my website. So if you're getting there, and if you guys, let's hear your future practices website. All right, so for those of you who are writing your homework down like in a note or a agenda or something, I will note there's a sheet in your folder. So, okay, first of all, I'm asking for 50 to 70% of problem set 3B to be 100% done. So you can check your work in the bottom, you can text me a question, no problem. But I'm not killing a dead horse or kicking a dead horse. So if you've got dimensional analysis and you can approach metric prefixes and you can approach those complex ones where it's multi-units and the word problems, you're good. But I'm leaving you some extra practice so that you can look at it some more on your own, or if you want to come to tutoring, we can do some of those extras. So just practice enough so that you're confident and you're retaining the information. The last set of Hustle videos tonight, it's due tomorrow. It's on chemical and physical changes. Who remembers that from like 7th or 8th grade? Like you've heard of chemical and physical changes. But you just may don't remember exactly what they are. Okay. So there are a couple of little like table notes that I provide for you. Like if there's a lot of stuff, I'll try to print out some of it, but the rest of it's on you. So just you can take notes on there or take notes on your own. So just make sure you watch the whole thing so I give you your full credit. We good here? Okay. Who's look back at the nanotech thing? It's okay if you haven't. Okay, I got 1 or 2 people. It's more than I was hoping for. Okay. So when you go back up here, Friday, watch the nanotech video. The PDF that you signed up on or the Google Doc that you guys signed up for is right here. Okay, now I've overwhelmed it. I've clicked it 3 times. Okay. So the very first thing you guys did was sign up on the Excel file where it says sign up. So I'm not going to click that for a moment, but I have gone through and said like narrow it or I've approved it. So if you need to go back and check, double check that. Some of us still haven't even signed up. Come on, like you just signed up for literally an idea. From there you have to go and think about how you want to present this information. So you can literally make a flyer, you can make a digital poster, you can make some sort of interactive public service announcement. It's not a PowerPoint because that's kind of like so last century, right? So we want to try to stay current. So inside of that assignment, here's what I'm expecting. Someplace you're talking about nanotechnology, right? You're talking about small things. Use measurement someplace. So speak to some sort of unit, and then in there show one dimensional analysis conversion. So if you're talking about like cancer cells, you might convert it from nanometers to kilometers. Now that's going to be a really silly conversion, but you're showing your process of dimensional analysis. Down here further, it says, in the field you're kind of investigating, list the benefits of the work in that field. The benefits can relate to advancements in the field, to our local community, to the global community, to our environment, etc. List the impact on your life or our future based on that field. So you guys chose some really interesting fields, so that should be a really interesting section. What are the future goals of that field or future applications of that field? So like somebody chose nanotechnology and batteries, like fuel and energy is a big topic right now, especially with climate change. And that you should have at least one source. So don't just say, I have no sources. You didn't pull it all of it from up here. Okay, so you're probably going to use at least one source. And if you're more comfortable with MLA, use that. If you're more comfortable with APA, use that. But just make sure you have that on the end of your poster in some way or form. And then down here, it tells you kind of what we're looking for. So you have some. You can also send me other ideas, more than just what's here. I just kind of got you started. But your peer, you're going to be talking to your peers. Okay, so bye, what's up,
Mine.